right? That should be up change. Right, up change, or the steepness of a line. When finding slope, you can either use the slope formula, which is this formula right here, okay, or find the rise over the run. That's what we're going to focus on in geometry, rise over run. Because you're not given the slope formula, which is another formula we have to memorize. You don't need your calculator today. Oh, you might like it, but I don't really need one right now. And we're going to focus on the rise over run because we're not given the formula. Okay? So all we're doing is just counting. So again, rise over run. Your rise is your vertical movement. Your run is your horizontal movement. It doesn't matter if you count up first or down first. I generally like to count up. But here, our rise against our vertical movement. So if we count our rise, what is our rise? It's kind of like you're making a right triangle. 5. We went down 5, right? So what's that 5 going to be? Negative. Our run against our horizontal movement. What's our run? 6. We went right 6, so that 6 is going to be what? Positive. So rise over our run, we said our rise was negative 5. Our run was 6, so the slope of that line is negative 5 over 6. Does negative 5 over 6 simplify? Nope. And if it did, still leave it like that. They're not picky on the OST, so I'm not going to be picky on the OST. Don't simplify a fraction unless it says to simplify the directions. Okay, but there's slope. Let's take a look at a few more examples. We just want to find the slope of these lines using rise over run. By my rise, I just like to count up first. Nice rule of thumb. So my rise, I'm going to count till I'm in line with the other point. How far did we count for our rise? 7. We went up 7, so it's going to be what? Positive. What's my run? 3. I went right 3, so it's going to be what? Positive. Rise over my run. What's my slope going to look like? 7 over 3. We take a look at B. What's my rise? Our rise, we went up, so it's going to be positive. What's my run? Negative what? 2. We went left 2, so it's negative. We went up 3, so it's positive. So my rise over my run will be, my rise was 3, my run is negative 2. Totally fine if you leave it like that. If that bothers you, just bump the negative up to the top. Also the same as saying negative 3 over 2. Totally fine to keep it like that. Question. If we take a look at C, our line was not graphed for us, so we want to find the slope between those 2 points. You don't have to use the slope formula. What could you just do? Yeah, just plot the points, right? Again, check how you plot them in Desmos. We're all human. We make mistakes. Double check it in Desmos. Negative 4, 5, and 2, 2. Again, follow your rise over your run. What's my rise? What is it? I couldn't hear. What was it? Positive 3. We went up 3, so it's positive. What's my run? My run. 6. So we went left 6, so it's what? Negative. Alright, so what would my slope look like for my rise over my run? It would be 3 over what? Negative 6. Totally fine if you leave it like that, but get in a good habit of simplifying, because we're going to be picky when you go into algebra 2, and you're going to have to simplify fractions. Okay? Right now, OST doesn't care, I don't really care. What does 3 over negative 2 simplify down to? Negative 1. Technically, that's the slope that you're going to do left. So it's 3 over negative 6, not the end of the world. Question. What are we using decimals for right now? If we take a look at point slope form, that's something else that you talked about in Algebra 1. Okay. Generally we use this when we need to write the equation of a line. Okay. And generally when we're given a point and the slope. Okay. Your y1 is just the y value of the point you're given. Your x1 is just the x value of the point that you are given. And n stands for your slope. This first x without the 1 and the y without the 1 always stays x and y. You just plug your x value in at the point, plug your y value in on the point, and then you have your f. Which is your slope. So when we write an equation of a line using point slope form, I'm given that my slope is 2/3 and it needs to pass through the point negative 6, 5. So I'm going to kind of fill it in the skeleton. Y minus something is equal to my slope times x minus something. That always stays a y, that always stays an x, that's always a minus, that's always a minus, and then you have your 3 blanks. Right? Slope always goes in front of my parentheses, so it's going to go in this blank in front of my parentheses. What's the slope? 2/3. Right? Then I have to plug my point in. If it's helpful, label what's the x value of this point. Negative 6 was the y value of this point. 5. X and then y. So the 5, the y value goes with the y. Okay? The x value goes with the x. And then you clean it up as much as you can. So we clean up y minus 5. No, there's nothing we can do with y minus 5. Equals, our slope is still 2/3. But here we have a double negative, so what's it going to turn to? A positive. I'm pretty sure if you left it like that too, the OST would say that's okay as well. Here's the thing, in Algebra 1 they had you solve for y. We don't do that in geometry. We stop. Right? That's all you have to do. I'm going to encourage you not to solve for y. Don't do it. You make room for error. You solve for y, you might actually do a multiplication error. You might do an addition error. Something might go wrong. Because we're human and it happens. Okay? So don't solve for y. Leave it like that. We're done. Make your life easier. Okay? You're allowed to do less work. Do less work. Okay? Don't do more than what you need to. Because you might make mistakes. OST is not going to know that. They're just going to see that you inputted the wrong answer. Okay? Watch. When we write the equation of a line, I fill in my skeleton. Y minus something equals something times x minus something. How are we going to fill this in? What's going to go in the blank in front of the parentheses? What's our slope? It's negative 4. This is x, first in the point, y second in the point. So I put my 12, or my negative 12 goes there. My positive 1 goes here. Y goes with y, x goes with x. We have a double negative here. What's it going to turn to? Positive. And everything else stays the same. That's a negative 4. Can't do anything with x minus 1. There's our answer. You don't have to solve for y. I know it seems very odd. You don't. Another shortcut is change the signs to the opposite. This is a positive 1. It became a negative 1. That's a negative 12. It became a positive 12. So if you want to kind of have a quicker step, shortcut is change the values to the opposite. If it's positive, it turns negative. If it's negative, it turns positive when you plug it in. The slope stays exactly how it is. You don't change the slope. Questions over that? No? If we take a look at this one. Which of the following lines has a slope of 5 over 2 and passes through the point 16, negative 2? See? I agree. It has my slope in the right spot. And my x and y change to the opposite. As a positive 16 is our negative. As a negative 2 would turn positive. Okay. The next type of line you talked about algebra was slope-intercept form. Right? Where B is the y-intercept and M is your slope. Okay? We generally don't use this when we're trying to write equations of a line. When we're given info, we use point-slope form. We only really use this when we're trying to graph a line, or it's already kind of written in this form and we're just trying to solve for it. So we don't really use this too much unless it's already kind of written in that form for us. So here what we want to do is put it in y equals ms plus b form. So intercept form. And then state the slope and the y-intercept. Well, if we look back, we want it in y equals mx plus b form. What do you notice is by itself? The y, right? So get this in y equals mx plus b form. What do we need to do? Solve for y. And to do that, what do we need to do? Subtract the 5x. To get y by itself, you just subtract the 5x on both sides. Cancels out. I'm left with y equals mx plus b. So x is first. I'm gonna write it first. You could write the x second, but sometimes we get our numbers mixed up if we don't write it in the right order. So x is first. I'm gonna write my negative 5x first, and then tack on my number plus 7. What is the slope? Negative 5. What is the y-intercept? 7. Slope is the number in front of the x. Y-intercept is just the number. Again, we need to get y by itself. What do we need to do first to get y by itself? Add what? Add the 6x to both sides. Move the x over first. That cancels. I'm left with 3y equals. My positive 6x is going to go first. And tack on my positive 15. To get y by itself, what do we need to do with that 3? 5. When I divide by 3, that cancels. 6 divided by 3 is 2. 15 divided by 3 is 5. What is my m? And what is my b? What's my slope? 2. Number with the x is my slope. What's my y-intercept? Last one again, we need to get y by itself. What do we need to do to get y by itself? What's our first step? Add 3x. It's a negative 3x, so to move it over, do the opposite. We're going to add. Cancels. We have negative 7y equals. Again, put the x first. Then I'm going to put my 28 after. What do we have left to do? We get y is equal to, again, you can leave it like this, totally fine. What's 28 divided by negative 7? 4. Find a 4. Y is by itself, so what is my slope and my y-intercept? So, if it's a negative, you can write it like that, or again, keep it like this, I don't really care. Both are fine. And what's my y-intercept? Questions over that? Those are the types of lines that you talked about in Algebra 1. This is the similar stuff that you are going to see in geometry. We're going to write equations of lines next week that have to do with geometry concepts. So what we're doing next week is more like what we did on the front. We're dealing with slope of parallel and perpendicular lines tomorrow. We're going to do more of this stuff tomorrow. So just wanted to refresh the basics, refresh your memory over those basics before we dive into new stuff and apply it to new stuff. So you're not trying to refresh your memory and grasp new concepts. So, kind of already talked about this. We also use slope-intercept form when we try to graph a line. Again, point slope is when we're writing an equation of a line. Slope-intercept form is if it's already written out for us, or we need to graph. Okay? In order to graph, what needs to be by itself? The y needs to be by itself. So we have 3x plus 4y is equal to negative 20. What do we need to do first to get that y by itself? So I get 4y is equal to, again, put the x first, and tack on the other number. What do I need to do to get y by itself? So y is equal to negative 3 over 4x. What is negative 20 divided by 4? Negative 5. There's our line. It's going to be helpful. Let's identify our slope in our y-intercept. What's our slope? Negative 3/4. The numbers from the x against our slope. What's our b? Negative 5. We use those to graph a line. Sorry. Start with your b. Okay? Start with your b. Do we start on the x-axis or the y-axis? The y-axis. The b is the y-intercept. So we start on negative 5 on the y-axis. Don't start on the x-axis. Not the x-intercept, it's the y-intercept. So start on the y-intercept. You're going to either go up or down, depending on if your y-intercept is positive or negative. And then you just follow your slope. It's negative 3 over 4. So which direction are we going to go first? Down 3 and then? Right 4. We can't go down 3 anymore. So we off our grid. Let's go back to your y-intercept. If we went down 3, right 4, what other direction can we go? We'll go 4. Up 3, left 4. And then we can't go anymore. Connect it with a nice, neat, straight line. And there we go. Alright. Questions over that? Okay. Rest of the time is yours to work on this practice.